Hi, hello, and welcome to the channel Backend Explained. In this video, I want to talk about two terms that almost every backend developer hears very early in their career: latency and throughput. At first, they sound simple, almost obvious. But once you start building real systems, especially systems under load, these two ideas get confused very easily. And that confusion often leads teams to optimize the wrong thing. So instead of starting with definitions, I want to slow things down and talk about how backend systems actually behave. Latency and throughput are often mentioned together. Sometimes they're even used interchangeably, but they're not the same thing. And more importantly, they optimize very different goals. This topic matters because performance is widely misunderstood. Many teams assume that if a system handles more requests per second, then users must be having a better experience, or that switching to asynchronous code will automatically make things faster. In practice, that assumption is often wrong. You can have a system that looks perfectly healthy on dashboards. CPU usage is stable, throughput is high, error rates are low, and yet users complain that the application feels slow. That gap between metrics and experience is where latency and throughput get mixed up. So let's start with latency. Latency is the time taken for a single request from the moment it enters the system to the moment the response is sent back. It includes everything along the way: waiting, processing, network delays, disk access, all of it. And the key thing about latency is that users feel it directly. If you click a button and nothing happens for 2 seconds, you don't care how many other requests the system is handling. You only care about the wait. That waiting time is latency. Throughput, on the other hand, is different. Throughput measures how many requests a system can handle over a period of time, usually per second. It tells you about capacity, about how much work the system can process overall. Throughput is important, but users don't experience throughput directly. Our system might be capable of handling thousands of requests per second, but if individual requests take too long to complete, the user experience still feels bad. This is where the distinction becomes important. Latency is about how fast a single request completes. Throughput is about how many requests the system completes in total. They are not opposites, and they are not interchangeable. You can reduce latency by processing fewer requests at a time, but that often reduces throughput. And you can increase throughput by allowing more work to happen concurrently, but that often increases latency. This trade off shows up very clearly in real backend systems. In practice, most backend systems are designed to optimize for throughput. We want CPUs to stay busy. We want connections to be reused. We want threads or event loops to handle as much work as possible. That design choice keeps systems stable under load. But it also means that requests are not always processed immediately. When a system is under load, requests don't disappear. They wait. This is where queues come in. Queues are not a bug, they're a deliberate design choice. They allow systems to absorb traffic spikes and continue operating instead of crashing. But queues also introduce waiting, and waiting directly affects latency. This is why increasing throughput often increases latency at the same time. Now let's talk briefly about synchronous and asynchronous execution, because this is where a lot of confusion comes from. In synchronous systems, a request waits at every step. If the system is performing I/O, the thread handling the request is blocked until that operation completes. This model is relatively easy to reason about, but it doesn't scale well when the system is under heavy load. In asynchronous systems, the request does not block the thread while waiting for I/O. Work is handed off, callbacks or promises are used, and the system continues handling other requests. This improves concurrency and throughput, but it does not eliminate waiting. And this is the trap. Asynchronous does not mean faster responses. Queues still exist, waiting still happens. Async improves how efficiently the system uses its resources. It does not magically remove latency. From the user's perspective, only one thing really matters: how fast the response feels, how predictable it is, how consistent the experience is. Users care about latency. From the system's perspective, we care about stability. We care about surviving load. We care about handling spikes without failing. Systems care about throughput. And this is the fundamental trade off. Lower latency often means limiting throughput. Higher throughput often means longer queues and higher latency. You can't eliminate this trade off. You can only manage it. Good backend systems are not built by blindly optimizing a single metric. They are built by understanding where the bottlenecks are, what users care about, and how the system behaves under load. Backend performance is not just about speed, it's about balance. Balance between capacity and experience, balance between throughput and latency. If you understand that balance, you'll make better design decisions, and your systems will fail more gracefully when things go wrong. Thank you for watching. If you found this video useful, please like, share, and subscribe for more backend learning videos. This is Backend Explained, and I'll see you in the next one.